Hello everyone and welcome back. My name is Mr. Krovald, and in this video I'm going to be going over the different structures, the structure of matter in the different phases. So we're going to look at solids, liquids, and gases and the structure of each of those and how they differ. Okay, so I'm using this site here at this um, web URL. I think this was a pretty cool one to use that gives you some good visuals. So I'm hoping this will be interesting for you to watch. So let's get into this. So structure of matter. So the purpose of this lesson is to explore a useful model for the structure of matter. This is called kinetic molecular theory. This is a very useful theory to help you understand what's going on at the molecular level for solids, liquids, and gases, and really lots of different properties of matter. So a model is basically a simplified version, a simplified approximation of what we see in reality. So remember that the actual structure of matter is more complex than what is presented here. So, what is kinetic molecular theory? So, we're going to begin by picturing matter as composed of spherical particles. So, just like this one here. And we're going to go through the different postulates of kinetic molecular theory. So, the first one is that all matter is composed of tiny particles. So, that's the first thing. We call these atoms or molecules. And so, that's the first thing you want to keep in mind, according to this theory. All matter is composed of tiny particles. Second, these particles are in constant motion. They're moving constantly, and they are constantly changing direction and velocity. So next is that number three, the amount of motion is going to be proportional to the temperature. So if you increase the temperature, this means that you're increasing the motion of the particles. So that means that temperature is going to be a measure of the degree of motion of these particles, how fast these particles are going, and so on. So if you increase the temperature, you're going to increase the velocity or speed of the molecules. If you decrease temperature, you're going to decrease the speed and motion or velocity of the particles. And finally, number four, we're going to see in the following animations the structure of solids, liquids, and gases. And we got to remember that these animations are based on a model and are therefore simplifications of reality. So, for example, real particles are going to be moving much faster than the particles we see in the animations. So, we got to keep this in mind that it's just a model. So, according to kinetic molecular theory, solids, liquids, and gases are going to differ in their freedom of motion of their particles and the extent to which these particles interact. So, that's the fourth part. So, let's get into this. Let's continue and look at solids, liquids, and gases. So, here on the right, we see the typical image of the particles in a solid. So in such an image, these particles are usually shown as packed as closely together as possible in very orderly planes. In fact, there is some empty space between them, and because of their constant movement, they are not quite as orderly as this image would suggest. So here you can see that we got these spheres, and they're kind of jam packed together in an orderly fashion. So you can see that they're lined up together. You could see the triangular pattern that they have, and you could see these layers of atoms, and they're kind of stuck in their place. It's not exactly like this. There is some freedom of motion here. They're not as orderly as this image would suggest, but they are pretty packed, and they do have a regular pattern. So let's move on. So if you focus your attention on the darker sphere, you'll note that due to the continual bumps by some of the particles and the tugs of others, it is constantly changing its direction and velocity. So you'll see here the dark sphere doesn't really move outside of this area here. It kind of stays in its general place here, this here. So despite the continual changes, the strong attractions between particles trap each of the particles in the small volume with the same particles surrounding it. So the dark sphere one doesn't really move away and outside of its surrounding neighbors. So it's kind of kept in that space there. And the same for any of the other particles. So this is what you would notice at least on the solid level if you're heating up a solid. And the one thing I want to kind of point out is that we're looking at the piston of an engine. So here, this would be your engine of your car. And so you can see the pistons here go up and down. And so as your pistons are moving up and down, they're gonna rub against the sides of the container here, the inside of the engine here. And so as they rub, friction is going to cause heat to be produced, and the temperature is going to go up, and then the particles are going to move faster. So I just want to kind of point that out to you. So if you get an increase in temperature, this is going to affect the structure of the solids. Remember that increased temperature leads to increase in the velocity of the particles. So as the piston is moving up and down, it's causing friction. Friction is causing heat produced. The heat is then going to increase the temperature and the velocity of the particles. So here they are moving faster. And so as each particle moves faster, it collides with the particles around it with more force. And this is going to push them slightly farther apart. And this is going to lead to a small increase in volume of the solid. Now, this is kind of dangerous for your car engine because um, if the piston heats up too much, one of the problems that could happen is that the volume increase due to the increased speed and motion of the particles in the piston. It can cause a larger volume. So, expansion of the solid inside here is going to make it so that the piston will seize inside the engine, and then that's going to cause problems. Okay, so let's move on. So if any solid is heated enough, the movements of the particles can be sufficiently powerful to push the other particles around them completely out of position. If one particle is moving fast enough, it can push adjacent particles out of the way entirely and move into a new position. For those adjacent particles to make way, however, they're going to need to push the other particles around them aside as well. So the organized structure then collapses and the solid becomes a liquid. So here we have a liquid now. Notice that the particles are moving quite faster. And look at the dark particle here. It can move out of its little sphere of space, and now it can move a lot further around. And so that is giving you the idea of what a liquid looks like. So the particles in a liquid are moving fast enough to break those attractive forces and push the other particles out of the way and move throughout the liquid. So this dark particle can break free of the interactions, the intermolecular forces, enough to move from one place in the liquid to another. So this is what causes the flow that we notice in liquids. Because each particle is moving throughout the liquid, they are eventually come to the surface of the liquid. So a particle's direction of motion or movement may carry it beyond the surface into the space above the liquid, but the attraction of the particles behind it usually draw it back again. On the other hand, if a particle is moving fast enough, it can move far enough away from the other particles to break the attractions pulling it back. This is the process by which a liquid is converted into gas. So the conversion of a liquid to gas is called vaporization or evaporation. So when we now have enough energy in the particles, you could see the dark particle there. And so the dark particle is going through the liquid, and eventually it comes to the surface, and you could see that if it has enough energy, it will break free. So you could see that the dark particle at times is moving up to the surface here. It seems to try to get away, but it's pulled back by the attractions of the outer particles. But eventually it will break free and move out into the space above. So therefore it becomes a vapor, it becomes a gas instead of a liquid. So this happens to many of the particles at the surface of a liquid. So the particles of a gas are going to be much farther apart than in a solid liquid. In the air around us, for example, the average distance between particles is about 10 times the diameter of each particle. This leads to the gas particles themselves taking up about 0.1% of the total volume. The other 99.9% of the total volume is empty space. So that is what happens when you have a gas. So most of the space is empty space. About 0.1% of the volume is taken up by actual particle space, by the volume of the particles themselves. So according to our model, each particle in a gas moves freely in a straight path until it collides with another gas particle or with particles of a liquid or solid. The particles are usually moving fast enough to break any attraction that might form between them. So after two particles collide, they bounce off of each other and join on, and then continue on their way alone. So here, the particles are moving so fast that when they collide, they're like billiard balls. They just bounce off of each other and ricochet and go off into different directions. And so that is what happens in a gas. Okay, so if you're riding on one of the particles, you would usually be so far away from other particles that you would think that you were alone in the container. In an instant later, you would collide with a particle that seems to have come out from nowhere. So the collision changes your direction and velocity. So these particles are so far apart, it's as if they're all by themselves, but they're also moving so fast that at any one moment they will collide and then change directions and speeds. So I hope that was helpful. That's the end of this video. If you found this useful and helpful, then please by all means like and share this video. Hit that notification bell. Join my channel. Subscribe to the channel. Hit that notification bell. And when you do, please click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think and let me know if you have any questions. I would love to hear from you. Thanks for joining me and have a great day.